Hello guys, how are you? I hope you're all doing well and fine and staying safe. Uh, on this lecture, I'm going to do the matrices. I'll just go for the first part of the matrices, which is the adding, subtracting, and multiplication of the matrices. And I will leave these other two parts for another lecture about the inverse and solving simultaneous. Right. So first of all, we'll start with the matrices. A matrix, like the definition of the matrix, it's a rectangular array of numbers with dimensions divided by the number of rows and column present. So basically, it just means like we refer to the matrices or to the matrix by referring the number of rows first and then the column. The numbers themselves are called the elements of the matrix. So each number inside the matrix here, it's called the element of the matrix. We refer to this matrix A as a 2 by 2 matrix because it has 2 rows and 2 columns. So these are 1 row, 2 rows, and 2 columns. This is 1, this is 2. And also for the matrix B, as we can see, it has 3 rows here. So that's 1, 2, 3, and 2 columns, which is 1, 2 columns. And the last one here is we refer to it as 1 by 3 because it has only 1 row and 3 columns. 1, 2, 3. Okay. A matrix with a single column is also called, we can call it as a column vector, as we did in the previous topic. A square matrix, it has the same number of rows and columns. So this is an example. It's 2 by 2 matrix, square matrix. The zero matrix, it has all the elements equal to 0. So basically, it just a matrix would have all the elements are zeros in it. And another thing is the diagonal matrix, which is a square matrix that has all elements equal to 0, except for those on the leading diagonal. As you can see here, the shaded with the yellow. This is the leading diagonal, which has the element not equal to 0. So we call this diagonal matrix. Another special type of matrix is the identity matrix. The identity matrix actually is a diagonal matrix with all its diagonal elements equal to 1. So, for example, I is 1, 0, 0, 1, which is 2 by 2 identity matrix, and the other one here, as you can see, is 3 by 3, because again, it has 3 rows and 3 columns. The identity matrix, it's always a square matrix. It has to be the number of rows same as the number of columns. Okay. Multiplying a 2 by 2 matrix by I, which is the identity matrix, leaves A unchanged. So A multiplied by the identity gives you A as well, same as it is. It won't change. Right. Matrix arithmetic here. We will these some examples will show how to add and subtract matrices, and also the next slide it's multiplying a matrix by a scalar number, a scalar, which means a number. So matrices with the same dimensions, which means same number of rows and columns, can be added and subtracted. So basically, to one of the conditions to add and subtract matrices, they should have the same number of rows and columns. So as you can see here in this example, the matrix A, B, and C. So we have three matrices. All of them is 2 by 2, because if they are not the same number of rows and columns, we can't add or subtract them. So to add and subtract, simply what we need to do is to add or subtract the corresponding elements. Okay, so I'll show you in this example here. I'll change the color of this pen, right? So, for example, A plus B here. So this is the first one here is A, and this is B. So to find the first element for the result, we do -2 plus 3, and that gives us 1. And we do the next one as 8 plus 6, and that gives us 14. And the third one is 3 plus 2, which is 5. And the last one, last element, is 1 plus 4, and that gives us 5. Okay, so this is the sum of the matrices A and B. So basically, we just add the corresponding elements. Another example here is B minus C. So again, what we will do, same as adding, but just in this case, we subtract. So each corresponding element, so from B minus C. So here it's going to be 3 minus 4. And for this one, it's going to be 6 minus 2. And for the next one, down there, for this one, 2 minus 1, and 4 minus 3. I'll just write them down here. So this is 4 minus 3, and this one 2 minus 1. Okay. So now we'll find the results. 3 minus 4 is -1. 6 minus 2 is 4. 2 minus 1, which is 2 plus 1, which is a 3. And 4 minus 3 is 1. So this is the result for B minus C. Okay. I'm just going to clear this. And show you the slides. Right. Another example here where A minus B plus C. So again, we do the same way. We just add and subtract the corresponding elements. So for first one, we're going to take -2 minus 3 plus 4. Okay, so that's -2 minus 3 plus 4. So I put here minus and plus because it's in the question minus and then plus, because they are A minus B plus C. And for the next one, it's 8 minus 6 plus 2, and we have 3 minus 2 plus 1, and the last one, let's do this, which is 1 minus 4 plus 3. And that will give us the final answer here, which is minus 1400. Right. Multiplication by a scalar. Before I start with the multiplication by a scalar, we'll do some more questions after I'll finish this video. I will give you some worksheet to practice, or you can try the example yourself, or you can watch any video or questions, practice some questions. I'll give you a worksheet basically to practice on these questions. Okay, multiplication by a scalar. Any matrix can be multiplied by a number. Yeah, for example, k here as a scalar. So we simply multiply each element of the matrix by k. So what we do, each element, we just multiply it by the number. So for example here, find 7m and minus 0.5m, given that m, the matrix here, is 2.56 minus 301. So what we were going to do here, we will multiply this matrix by 7, and we'll multiply it again by minus 1. Let's have a look. So basically 7m means 7 times this matrix. And what we will do here, as we said, we're going to multiply each element by the number 7 itself. So that means going to be 7 times 2, and 7 times 3, 7 times half, 7 times 0, 7 times 6, and 7 times 1. Okay. Right. So this is going to be 7 times 2 is 14, 7 times half means 7 divided by 2, which is a 3.5. 7 times 6 is 42. 7 times minus 3 is minus 21. And 7 times 0 is 0. 7 times 1 is 7. So that's the answer. Then now, for next one, it's minus 0.5 m, so that means minus half. So you can write it this way, minus 2 multiplied by m. So that's minus half multiplied by the matrix itself. So again, that means minus 2 times 2. Yeah, just that means it's minus 2 times 2. I'll just show you here. So it's minus half, sorry, not minus 2, minus half times 2, and minus half times half, and minus half times 6. And down there is minus half times minus 2, sorry, minus 3, minus half times 0, and minus half times 1. Okay, and that will give us, so I'll just show you this. Okay, this 2 will cancel with this 2, so it's minus 1 here, and minus half times half is minus 1/4, 1/4, or minus 0.25, same. Minus half times 6 means 6 divided by 2, which is minus 3. And minus half times minus 3. Minus times minus is plus, then it's a 3 over 2. And this is 0. Minus half times 0 is 0. Minus half times 1 is minus half. Okay? Or you can even leave it as minus half. I'll change it. Okay. I'll just, so this is minus 1. 1.5 means the 3 over 2. And minus, well, I'll just clear the screen first. And I'll show you this. Okay. So this is the answer here, as you can see. Right. So this is minus 1, minus 0.25, it's same as minus quarter, minus 3, minus 1/2 is same as minus 0.5. This is just 1. And 3 over 2, same as 1.5 and 0. So this is just to explain to you why it's written as in decimals or a fraction. Both are the same thing. Right. Matrix multiplication. We can multiply matrix A by matrix B to form the product AB, provided that the number of columns of A equals the number of rows of B. So we can multiply two matrices, but the condition is the number of the columns of A equals the number of rows of B. Okay, so the product, which means the result of AB, will be another matrix, let's say it's C, and this result, it will have the same number of rows as A and the same number of columns as B. Well, when we'll try this with numbers, it will be easier for you to understand. So basically, if a matrix A multiplied by B, the answer will be another matrix, which is C. So let's say, and the condition is the number of columns of A equals the number of rows of B. And the answer, the results one, it's going to have the same number of rows of A and the same number of columns of B. Right. So for example, here we have matrix A here. Yeah. A is how many rows? There are 2 rows. Yeah, that's 1, that's 2. So we call it 2 by how many columns? 3. And the matrix B is how many rows? 3 rows and 2 columns. Okay, so what we want, if we want to find AB, let's say AB means, so AB means 2 by 3, and B is 3 by 2. So if we have these two, if we have these two in the middle are the same, let's start, I just need to change this. Okay. Wasn't this 2 times 3 and this 3 times 2? Okay, what we need to have is these. If these two numbers are the same, then that means we can multiply these matrices together. Okay, the dots in the middle, they have to be the same. And in that case, the result will be same as these, the outside. So the result here, it's going to be C. Okay, so that's equal to C. And C in this case is going to be 2 by 2. Right? So as I said, if A is 2 by 3, B is 3 by 2, so then we can form the product AB, which will be 2 by 2, as I explained here. We can also form the product BA. Yeah, if we do BA, the answer will be 3 by 3. I'll show you why. Because if we want to do BA, that means B. Right. Okay. I want to do BA. Say BA. That means for B, it's a 3 by 2. And A is 2 by 3. So again, in this case, I can find the two in the middle are the same, which is 2 and 2. So that means I can multiply B by A. And my answer will be 3 by 3. As you can see here, the answer is going to be 3 by 3. But just to let you know that AB, it's not same as BA. Okay? AB is not same as BA. So just remember that. AB, it's not same, not equal to BA. Right. Don't worry, I'll give you some questions to try at the end when we finish. Okay. So this is example 3. To form a product, we multiply the column of the right-hand matrix by the row of the left-hand matrix. So this example here is going to show us how to multiply the matrices. Okay. So we have A here, as I said, this is 2 by 3. And B is 3 by 2. Right. So to multiply, we will start with the row from A. We multiply this row by this column from B. Okay, and I will show you now. So A times B is, this is A multiplied by B. What is going to happen now is going to multiply this row. I'll show you with, so basically we're going to do, okay. So what we will do here, I'm just going to do the first element, let's say. I'll take this row multiplied by this column. Okay, so this is going to be -2 times 1. So this times the first one, then plus 8 times -4 plus 1 times -2. So all this, find the elements on the new matrix. Okay, so I'll show you this now for the rest. Well, let's do the other one actually, just to show you. Right. So if I want to do the second one down there, I will take this row, multiply by the first column again. So this is going to be 3 times 1 plus 1 times minus 4 plus 6 times minus 2. Okay, and for the next value, which is this, I will take again the first row, multiply it with this column. So this is going to be minus 2 times 2 plus 8 times 3 plus 1 times 5. Okay, and for this one, it's going to be, let's just change the color here, right? So it's going to be the second row with the second column. Maybe too many colors now here for you, just to show you how to work it out. And there's going to be 3 times 2 plus 1 times 3 plus 6 times 5. And we close the matrix. Okay. And then we find the result for it. It's already there in the slides. I'm going to show you the results for it. So I'll just clear. Yeah, this is just to show you the thing, how to multiply. Let me just to clear this first. Erase. Okay, and now, and this will show you here as well. So this is the row multiplied by first column to give you this first element, the shaded in yellow. Okay, and the same method to follow to find the other elements in the matrix. And you simplifying, that means after you multiply and add up, you have the answer here, minus 3625 minus 1339. So let's check the first one here. We have minus 2 times 1, which is minus 2. So that's minus 2 plus 8 times minus 4. So that's minus 32. And plus 1 times minus 2, which is minus 2. So minus 2 minus 32 minus 2 is minus 36. This. Okay. So that was the answer for AB. And same method exactly. Now we'll use, but we're going to do B multiplied by A. Again, you will multiply, you take the first row from here, multiplied by first column from here. So first of all, like we know for this one, we have this 3A, it means 3 by 2, and this is 2 by 3. Because these two are the same, that means we can multiply them already. Yeah, and the answer we would expect it to be 3 by 3. The result, 3 rows and 3 columns. So this is just to show you, like 1 times minus 2 here, 1 times minus 2 plus 2 times 3. The same way you find the other one. And to find the second one, which is highlighted in yellow, you use the second column multiplied by the, second row multiplied by the second column. That gives you these elements in, will give you this element here in the middle. And second row with a third column will give you this one, the last one, like minus 1, minus 4 times 1. plus 3 times 6. Again, after you simplify, you get the answer BA is 4, 10, 13. And you can see this is BA is different than AB. The AB was 2 by 2, and BA is 3 by 3. So they are different. Sometimes it's possible to find AB, yeah, but not BA. So for example, if the matrix A is 2 by 3, so if we do, sometimes this note here, this is very important for you to know and remember. If A is 2 by 3 and B is 3 by 1, so that means AB is 2 by 3 and B is 2 by 1, because these two numbers in the middle are not the same. Yeah, as you can see, this is the 3, not same as 2. Then that means we can't multiply A by B. Okay. No, sorry, just a minute. Okay, so that was actually B is 3 by 1, not 2 by 1. Sorry. That's B was 3 by 1. Just as following the example here on the slides, then if 2 times 3 and B is 3 by 1, then we can multiply them together and the answer will be 2 by 1. Okay, the answer will be a matrix 2 by 1. But if we do B by multiplied by A, so that's what I wanted to explain really. So if we do B multiplied by A, and B, as we said, it's a 3 by 1, and A is 2 by 3, then in that case, we can't multiply them. We cannot form B by A because these two numbers in the middle are not the same. So as you can see, 1 is not same as 2. Okay, so we can't multiply them. Right. Okay. So that's what's really you need to know and remember about multiplying the matrices. So it's not possible to, also just to remember, it's not possible to divide two matrices together. So we can add, subtract, and multiply matrices, but we can't divide two matrices together. Okay, so that's all for today, and I hope you understand the way of how to add, subtract, and multiply the matrices together. If you have any question, let me know. I will do a live session with you, and you can ask me if you have anything, or you can send me email, or I'll give you some worksheet. I want you to work it out and submit it as well. Try to join I want you to join the group of the teams as well. So if you have any question or anything you want me to explain, and that's it for today. And I hope you find it easy to follow. And good luck with the questions to do. Okay, the questions there for the matrices are on the VLE, especially the first page. The first page of the matrices, it's about adding and subtracting the matrices, and some multiplication as well. So it's exercise 10A and 10B. Yeah, 10A and 10B. You will find this on the VLE. So I want you to do that as well. Thank you. Have a nice day. Bye.